thing. You got it. Woo! Okay, I got it. I've got to pump myself up. What is length contraction? So length contraction is when objects moving at high speeds. So again, we're talking about close to the speed of light. Appear smaller from an outside frame of reference. Okay? So, from an outside perspective, something will appear smaller. So let's use the example I've been using about the rocket ship. So not only will someone on Earth measure my time to be different than I will, they will also measure this length of the spaceship to be different than I will. So when the spaceship is on Earth, it will look like the regular size. Let's say it's 100 meters long. But while it's going through space, if they were to measure it, it would not measure 100 meters long. It might measure 90 meters long or 80 or whatever, depending on the speed. The faster you go, the more it will contract. So if you go really close to the speed of light, it will appear almost to be 0. It's only shrunk horizontally. It's not shrunk vertically as well, because the motion observed is only going to be contracted in the direction of motion. So if I were to go up, it would shrink this way, not this way. If I go forward, it shrinks this way, not that way. All right, let's see if you guys can predict the reason. What is the cause of this? Anyone think they know? Why? Why? What do you think, Jess?
Could distance also take part? Like how far away it is?
Yep. Remember, speed of light has to be constant. So c equals d over t. So the time dilation is an issue, but the distance is also an issue too. In order to keep c the same, the distance and the time, the length of an object will change. So the reason why length contraction occurs is because speed of light must be constant. Okay, let's think of it in a different way. Go back to that nebula example. So here's Nebula. She's on the planet. Here's my Guardians of the Galaxy guys on a spaceship, which is apparently much shorter than the first one I drew. Okay? Remember that they measured their trip to take 2 hours, but she measured the trip to take 2.5 hours. If they're measuring different distances, if they're measuring different times, but they're measuring the same thing, the speed of light has to be the same. What has to be true about her distance compared to theirs? They have to measure different distances. Okay? So, Nebula sees their time slower. So what has to be true about their distance from her perspective? It has to be shorter. So therefore, from their perspective, they travel less distance in less time, which means the object gets smaller. Jess?
Isn't it like the same logic when you look up at the plane? It looks like it's passing by so slowly up the air.
That has a little bit more to do with perception. But it's a similar idea. So objects that are further away are going to appear differently because it's a little bit different than frame of reference, but it is, your perspective is different than theirs to an extent. Yeah. So you have to measure a different distance than before. Okay? Questions? All right, we're going to make life all better. Okay, I'm going to make life all better. Things sound really confusing. but it's about to be warm and fuzzy and comforting. Oh yeah, here we go. Now we're really going to be cooking here. There we go. We'll finish up with this. Okay, here we go. First things first, to make life all better, here is 1 minute of bunnies sitting inside of cups. See, it just makes me want to get one of those. While this is going on, I'll pass out the practice for you here. Okay, but if bunnies aren't enough, okay, and it makes sense, we need a little bit more than bunnies. Here is adorable purring kittens. See, feel the stress washing away. The kittens, they don't know that time doesn't stay constant, right? To the kittens, it's just life, right? Time goes forward. They lay in an adorable pile in a basket. They don't care that time and length change, okay? They don't worry about the velocities of objects added together. So take comfort in the sweet, sweet, sweet sound of small, adorable kittens. Okay? But I know some people are like, oh, it's just way too sappy. So here is the most adorable, deadly creature of all time.